effect is often illustrated by the sound of an ambulance. When an ambulance is moving towards you, you perceive the sound, the frequency, as higher than what it actually is. When it's moving away from you, you perceive the sound as lower than what it actually is. We perceive another frequency than the actual one, but they are related to each other. Which frequency we experience is related to the speed of the source, observer, and the speed of the waves in the medium. If the source and observer are moving towards each other, the perceived frequency is higher than the actual frequency. Consequently, if the source and observer are moving away from each other, the perceived frequency is lower than the actual frequency. So, for example, if we presume that an ambulance is standing still 1 kilometer away from you, it would take approximately 3 seconds for the sound to reach you, since the speed of sound is around 340 meters per second. If the ambulance sounds for a minute, you will perceive the sound as 3 seconds of silence, followed by 1 minute of sound. So, now, let us presume that an ambulance is moving towards you. In this scenario, the siren of the ambulance starts 1 kilometer away from you. Therefore, it still takes 3 seconds for the first sound to reach you. After 1 minute, the ambulance is almost beside you, and consequently, the sound is reaching you the same moment it's leaving the ambulance. This means that the sound from the siren has been on for a minute, but for the observer, you, the sound has compressed to 57 seconds. The number of dispatched airwaves is exactly the same as the moment the ambulance stood still. The difference is that they have compressed and acquired a higher frequency. The precise phenomena reverse proceed when the ambulance is moving away from you. The frequency becomes lower because it takes more time for the airwaves to reach you. The Doppler effect has many possible practical uses. For example, it can be used when it's necessary to describe change in time or differences in frequency. Echo can decide distances and speed of an object. When the Doppler effect is applied on light instead of sound, it's called redshift. With this method, it's possible to interpret how the universe expands in size. Thank you.